previous lecture, I have started the application of linear programming problem in operations. We have taken one problem on production scheduling, then we have solved it. In this lecture also, I am going to take another problems in the area of operations. I am going to formulate it and solve it. So, the agenda for this lecture is, I am going to take one problem on make or buy decision, because in operations area this is a very common problem, whether we have to make the component in house or we have to buy it from outside, from the vendor, from the suppliers. The another example is workforce allocations. These are the two examples which I am going to cover in this lecture. The problem is like this problem is taken from Anderson et al. A company is preparing to introduce two new calculator, one for the business market called the financial manager and one for the engineering market called the technician. Each calculator has three components: base, electronic cartridge and a faceplate or top. The same base is used for both the calculators, but the cartridges and tops are different. This base is common for both type of laptop, whether it is a financial manager or technician. All components can be manufactured by the company or purchased from outside the suppliers. So, we are going to suggest which components has to be manufactured in house or which components need to be purchased from outside. And there are manufacturing cost and purchasing price for components are summarized in the table which is given here. This table shows the component for the price, the manufacturing cost and purchasing price. For example, this base component you can manufacture it, this is the manufacturing cost, and you can buy it from outside also, this is a purchasing cost. You see that always purchasing cost is higher than the manufacturing cost, manufacturing in house. So, this problem, the make or buy decisions, these 5 components. So, we are going to suggest out of this 5 how many quantities in each category of the component we are going to do it ourselves or we are going to buy from outside, that is the make or buy decision. The company forecast indicate 3000 financial manager calculator and 2000 technician calculator will be needed, but the problem is the manufacturing capacity is limited. Apart from manufacturing capacity, the company has 200 hours of regular manufacturing time and 50 hours of overtime. There is a possibility apart from regular manufacturing time to go for overtime. So, the available overtime is 50 hours. But when you go for overtime, that involves a premium at the additional cost of $9 per hour. Okay. This table shows the manufacturing time for each component. Okay. So, if it is the base, is this in terms of minutes? This is minutes. Financial cartridge 3 minutes, technician cartridge 2.5 minutes, financial top 1 minute. So, if you manufacture, this is the time taken for manufacturing for each component. Now, the problem is to determine how many units of each component to manufacture and how many units of each component to purchase, that is make or buy. Now, we will discuss about the decision variables, because for each decision variables, if it is manufacturing there will be one decision variable, if it is the purchasing there will be another decision variables. For example, when I say BM, base manufactured, BP, base purchased, FC, financial cartridge, M means manufactured, M represents manufacturing, P represents purchasing from outside, FCP. So, like that there are 5 components, there are 2 possibilities, we can make or we can purchase. So, there will be 10 decision variables 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Apart from the decision variables, we have to introduce one more decision variables for overtime. So, one additional decision variable is needed to determine the hours of overtime must be scheduled. So, the decision variable for that is OT, number of hours of overtime to be scheduled. So, now this objective function which I am going to formulate will have three components. There will be a manufacturing cost, there will be a purchasing cost, there will be a overtime cost. So, we have to add all these costs, that cost has to be minimized. If you want to minimize, how much component has to be done in house, how much component has to be purchased from outside, and how much overtime we should utilize, because there is a cost for overtime also. So, the objective function is to minimize the total cost. Using cost per unit data, this table, the overtime premium cost rate $9 per hour, which I have mentioned in the previous slide, we can write the objective function. So, 0.5 BM, 0.6 BP, base for manufacturing, base for purchasing. Similarly, FCM for manufacturing, then FCP for purchasing. So, TC M for manufacturing, TC for purchasing, FT for manufacturing, FT for FT is a financial top for purchasing, TTM manufacturing, technician top, TTP that is purchasing. Then 9 OT, because there is a $9 for each overtime hour. Now, we will write about the constraint. The first 5 constraints specify the number of each component needed to satisfy the demand of 3000 financial manager calculator and 2000 technician calculator. Why there are 5 constraints? Because there is a 5 components. A total of 5000 base components are needed, with the number of other components depending on the demand for particular calculator, because the same base can be used for both type of calculator. So, the total number of bases required is 3000 plus 2000. So, the 5 demand constraints are given like this. So, for each variable when you add it, B manufacturing, B purchasing, the total should be 5000. Okay. For the second one, financial cartridge, we can manufacture and purchase, that should be 3000. Technician cartridge, that when we manufactured or purchased 2000, 3000, 2000. So, these constraints are given. Now, as I told you that overtime cannot exceed 50 hours. Okay. So, there are 5 constraints for each component, there is a overtime constraint. Now, we have to introduce another set of constraint. So, the second constraint states that the total manufacturing time required for all components must be less than or equal to the manufacturing capacity, including regular time and overtime. What does this constraint says? That the total manufacturing time should not exceed your total manufacturing capacity, that includes your overtime also. So, the manufacturing time for components are expressed in minutes. You should be very careful, the table which I have shown previously, because that is values manufacturing times are expressed in minutes. So, when you write the constraints, you have to make sure that both the side we have same unit. So, we state the total manufacturing capacity constraint in minutes, because we know that there are 200 hours of regular time capacity. So, when you converting into minutes, so 60 multiplied by 200, there will be 12,000 minutes. The actual overtime required is unknown at this point. So, we write the overtime as 60 overtime minutes, because we are writing overtime also in terms of minutes, that is why 60 OT. Now, when you bring this one, you see that the base will consume 1 unit, this is minutes, the time is in minutes. Okay. So, 1 BM plus 3 FCM plus 2.5 TCM plus 1 FTM plus 1.5 TTM, that should be less than or equal to your manufacturing time capacity plus overtime, because we are talking about only the manufacturing, there will not be any the variable which has P, because P represents purchasing. We are not bothering about purchasing. Now, this is our complete problem. What are the complete problem? We have to minimize the objective function. So, objective function take cares manufacturing cost, purchasing cost and manufacturing time and overtime. So, this constraint for demand, this constraints for our OT, this constraints for total available manufacturing time including overtime. So, when I solve this, this is the output which I got it. So, now with the help of solver, I will run this solver in Excel, then I will come back to the interpreting these answers. I have formulated an Excel solver. So, this is the place where we are going to get the answer. I have entered all the constraints. So, my objective function is here, objective function is in your R5. So, now I go to solver via data solver. See, remember this is minimization type because we have to minimize the cost. So, when I solve it, so this is our value of objective function. Suppose I want to see the output, I will go back solver again. After solving, please select answer sensitivity limits. Okay. So, now here we have the answer report. Answer report, this can be formulated like this. Yes. So, we are getting here answer. The BM base that has to be manufactured 5000. Okay. Base that thing need not buy from outside. This solution suggests we need not buying from outside. So, financial cartridge, this has to be manufactured, some quantity has to be manufactured, financial cartridge, some quantity has to be purchased. See this one, this has to be manufactured, technician. The second one 0, need not purchase. So, FT 0, but FT this has to be purchased. Then when you go to sensitivity analysis, here we can see the reduced cost and the dual value. So, there is a reduced cost is there is a dual value is there. The dual value is under the column of shadow price. Now, I have taken the screenshot of this answer. So, that I will explain how to interpret these values. Now, we will interpret the output of our solver. So, what we are inferring from here, you see that our final objective function value is 24,443. Okay. So, the other thing is we see the BM is 5000. So, what this says, the optimal solution indicates that all 5000 bases and 667, this one approximately 667 financial manager cartridges and 2000 technician cartridges, sorry 2000 technician cartridges here. Here 2000 technician cartridges should be manufactured. So, there are 3 elements 1, 2, 3 that has to be manufactured in house. Other things remaining 2333 financial manager cartridges, this one, this and FTP, TTP. Okay. This has to be purchased from outside. Now, we are getting the final answer, how much quantity has to be manufactured in house, how much quantity has to be purchased from outside. No overtime manufacturing is necessary, see that the value for overtime is 0 and the total cost associated with the optimal make or buy plan is this much 24,443. Now, we will interpret the sensitivity analysis report. The sensitivity analysis provide some additional information about the unused overtime capacity. Here when you look at here that the final we are not using any overtime value, but the reduced cost is 0, the reduced cost is 4. So, what it says that The coefficient of our overtime in our objective function is 9 OT. Okay. So, if the cost of overtime is decreased by 4 more units, then we will get a positive value for the OT. So, what it implies that if the overtime premium is 9 minus 4, that is $5 or less, the company may want to replace some of the purchased components with components manufactured on overtime. So, what it says that if it is 5 OT, what will happen? There will be a possibility we will be forced to use OT, because that will be beneficial for you. Okay. That is the interpretation of this reduced cost. Then we will interpret the dual value. The dual value for the manufacturing capacity constraint 7 is minus 0.083 here. Okay. This value indicate an additional hour of manufacturing capacity. Okay. So, when you additional hour of manufacturing capacity is worth of 0.083 per minute. Otherwise, if you convert into time, this is $5 per hour. The right hand side for the constraint 7 shows that this conclusion is valid until the amount of regular time increases up to 12 plus 7, $19,000, 19,000 minutes. Otherwise, 316.7 hours. So, the sensitivity analysis also indicate the change in prices charged by the outside suppliers can affect the optimal solution. Actually, what we are talking about, this range of optimality. Remember, range of optimality. Remember, when I was explaining about sensitivity analysis, I was explaining two terms. One is range of optimality, second one is the range of feasibility. What is the range of optimality? If the coefficient, what is the allowable change of coefficient of the objective function? For instance, the objective function coefficient range for this BP, variable BP. What is the BP? Base when we are purchasing. The range is 0.583. How we got this range? For example, here the current value is 0.6. So, the upper limit is 0.6 plus, because it is a very big value. The lower limit is 0.6 minus 0.017. So, that is nothing but your 0.583. There is no upper limit. So, what we are inferring from this, if the purchase price for bases remains, the range remains $0.583 or more, the number of bases purchased will remain at 0. However, if the purchase price drops below, because the lower limit is 0.01, 0.583, if the purchase price drops below this, instead of buying, the company should begin to purchase rather than manufacture the base component. Okay. No. However, if the purchase price drops below 0.583, the company should begin to purchase rather than manufacturing. Currently, we are, see that BP, we are not buying from outside. When the range goes beyond the limit, then we should think of. However, if the purchase price drops below $0.583, the company should begin to purchase rather than manufacture the base component. Dear students, in this lecture I have explained application of linear programming problem for make or buy decision. I have taken a problem that I have formulated, then I have solved with the help of Excel, then I have explained the interpretation of that output. The next lecture we will take another problem on operations area, then we will solve and interpret the result. Thank you very much.